Okay, so we're gonna start factoring today. Um, and we'll make connections with the division a little bit later, but when we were dividing, I kept saying, right, if something divides evenly, then what do we know? It's a factor. Yeah, then they're factors, right? So today we're going to look at factoring polynomials, and specifically we're going to look at factoring the greatest common factor out, GCF, right? The greatest common factor. Okay. So let's look at a couple examples. Let's look at 35 x to the fourth minus 49x plus 7. Okay. When we factor, we always start with this process. This is the first thing that we will always do. And we're looking for the largest number that goes into all three of those. 7, right? 7 is the largest number that goes into all three of those. So we're going to factor a 7 out. And then in parentheses, we're going to write what's left. So if I take 7 out of 35, what am I left with? 5. So I have 5x to the fourth minus, if I take 7 out of 49, what are we left with? 7x. And then 7 out of 7 leaves me 1. 7 out of 7 leaves me 1. It's kind of like dividing. 7 divided by 7. And that is factored. Okay.
So do we solve it?
No,
Or that's it?
that's it. When we factor, we're not solving. All we're doing, okay, let's just go back to just basic numbers, right? If I asked you to factor 15, what would you write? 5 times 3, right? I'm not solving it. I'm just rewriting it. I'm writing it in a different form. That's what we're doing when we're factoring. We're just writing it in a different form. Okay. So let's look at, negative 9 plus 27n plus 15n squared. When we give you things to factor, it'll be written like this. Notice that there's no equal sign because there's nothing to solve. We're just rewriting it. So if I want to factor this, right?
There's an equal sign up there.
There's an equal sign there because we started with this, right? And we factored it, and I said, okay, that's equivalent to that. But when you're given the initial problem, there won't be an equal sign. Okay? We're going to write the equal sign because we're stating that they are equivalent, just like we stated that 15 is equivalent to 5 times 3. But we're not solving anything. Okay? So when you are asked to factor, one of the ways you know that you're not solving it is that you won't have an equal sign written there. Okay? You're going to put the equal sign because you're telling me that they are equivalent. Okay, so what are we going to factor out of this? What's the biggest thing that goes into negative 9, 27, and 15? 3. Good. So we're going to say this is equivalent to, we're going to take a 3 out. You could take a negative 3 out, but I'm going to leave it positive.
Well, no, I just meant in the parentheses.
Okay, good. So if I take a 3 out of negative 9, I'm left with negative 3, because negative 9 divided by 3 is negative 3. And it'll be plus, when I take a 3 out of 27, what are we left with? 9n plus 3 out of 15, 5n squared. You know what? Right now, we're not going to worry about that. Okay. We will do that probably starting tomorrow, actually. Okay. Okay, let's look at another one. Okay. 20p squared plus 30p to the third minus 30p to the fifth. Okay. Now, what's the biggest number that goes into 20, 30, and negative 30? 10. Okay. So we're going to take the 10 out. Now, this one's different because all three of these numbers have a p in them. See, up here, these both had an n, but the 9 did not. Since they all have a p, that means I can factor a p out as a greatest common factor. So I'm going to take out a p, and I'm going to take out actually a p squared. So when we're factoring the greatest common factor, if they all have the variable, we want to take a variable out, and we want to take out the lowest exponent. So in other words, I can't take out p to the fifth, right? P to the fifth means I have 5 p's, right? I can't take out p to the fifth because this one does not have 5 p's. I can't take 5 p's away if I only have 2 of them. So we always take out the lowest exponent of the variable. I'm going to take 2 of the p's out of everything. Okay, so let's figure out what's left. I took 10 out of 20. What's that leave me? 2. I took p squared out of the p squared, so there's no more p squares. Basically, it's 1, right? But we don't have to write the 1. I took let's do the next one. 10 out of 30 leaves me 3. Now I took p squared out of p to the third. How many p's are left? 1. So it's p to the first. Okay, and then we're going to do minus. We're going to take 10 out of negative 30, which is negative 3. And here I had 5 p's and I took 2 away. So what's left? P to the third. And there is my factored polynomial. Okay. We always take the lowest exponent out, but they all have to have that variable. Okay, so let's look at this one. Let's do negative 100 v to the third plus 70 v squared plus 90 v. Okay. What's the biggest number that I can take out? 10. Yeah, let's take out a 10. Can I take any v's out of there? Yeah. How many? Yeah. Just 1. Good. Okay. What's that leave me? Plus 9. Who has a question on that? Try one by yourself? Okay. Okay, let's do 12x to the third minus 42x squared minus 48x. Go ahead and factor that. Okay, so we're going to work through this together. Okay. So when I'm trying to figure out the greatest factor, right, I want to find the biggest number that goes into all of them. Well, they're all even, so I know 2 goes into all of them. But that's not the biggest number. 3 goes into all of them, but that's not the biggest, right? So when I start doing that, I'm like, oh, well, maybe it's 12. Well, 12 goes into 12, 12 goes into 48, but 12 does not go into 42, right? So it's going to be 6. 6 goes into all 3 of them, and that's the biggest number that will go into all 3 of them. Okay? So we're going to take a 6 out. How about the x's? How many x's can I take? 1, yes. Okay. So, Tony, what does that leave me with the first term? 2x squared, good. Okay, leaves me with 2x squared. Hunter, how about the next one? There you go, negative 7x. And Ronnie, the last one? Yeah, minus 8. And we're done. Okay. All right, who has a question for me? Okay, give me a fist of 5. Look at you guys. Wow. All right, I have a worksheet. I think we'll have time to go over this worksheet, so go ahead and complete it. You're going to upload it to Google Classroom, and then we'll go over it, okay? Okay, so looking at the first thing, right away we see that they all have ends. So I know I can take some ends out. How many ends can I take out? 4, yeah. Okay, we're going to take out 4 of them. So we're going to take n to the 4th out. Now I'm looking at the numbers. What's the biggest number that goes into 30, 18, and 9? 3. Okay. So when I take 3 out of 30, I'm left with 10. And if I take n to the 4th out of n to the 7th, I'm left with n to the 3rd. Right? I'm taking 4 n's away from the 7 n's. That leaves me with 3 of them. Okay. Hunter, what's left when I take the 3n to the 4th out of 18n to the 5th? 6n, good. And the last one, Anya, what's left on the last one? 3, perfect. Okay. One of the things that you can do to check yourself, after you get to this point, take a look at what's left inside the parentheses and basically say to yourself, is there anything common that I can take out of it? For instance, let's just say that after you did it, let's say you had 10n to the 4th plus 6n squared plus 3n left, right? So looking at that, I'm like, oh, wait, they all still have something in common. I can take an n out of there. So then you take another n out. Okay, so you can check yourself to see if you factored out the greatest common factor. Okay, number 2. Damien, what can I take out of number 2? 2. All I can do is take a 2 out. This 4 does not have an r, so I can't take an r out of there. So that leaves me with 2 plus 3r plus r to the 3rd. And we're done. Okay? Huh? On this next one, on number 3?
No, for I put 1 R third.
Oh, I'm sorry. I thought you said 9. I'm sorry. You could put a 1 there if you want to. You don't have to. Anytime it's a 1, you don't have to. But it's not wrong to put it there. Yep. Okay, number 3. Biggest number we can take out of there is a 9. If you took a negative 9, that would be okay. But either one are acceptable. Okay. So if we take a 9, that's going to leave me with negative 5 minus 5m minus 3m to the 3rd. also acceptable. If you take a negative 9 out of there, it would leave us with a positive 5 and a positive 5m and a positive 3m to the third. Both of those are acceptable answers. Okay. Okay, number 4. Jakaya, what did you take out of number 4? 10. Yeah. Take a 10, and that leaves us negative 2r to the 5th plus 9r plus 9. We're going to finish really early, aren't we? Yeah. Well, I'll introduce the next thing, but I won't give you homework. Okay. Okay, number 5. Jonah, what'd you take out of it? 2. Yeah, because if you look at the 6, the factors are 1, 2, 3, and 6. Well, 6 does not go into 10, so the biggest number we can take out is a 2. Can you take anything else out? X, 2x, yes. Leaves us with negative 5. If I take x out of x, it just leaves 1. Plus 5. X out of x squared leaves us with x. Minus 3. X out of x to the third leaves us with x squared. Okay. Okay, number 6. Grady, what you take out?
I got 3.
3, yes. Leaves us with 8 minus p plus 5p to the 4th. Okay. All right, Ava, how about number 7? Good, yeah, p to the second. I can't take any numbers out. There is nothing other than 1 that goes into 2, 4, and 3. So I can't take anything out. If you want to put a 1 there, that's okay. All right, it leaves us with 3p to the second plus 4p minus, now here's the trick. We took a p squared out, so it's minus 2, and there's no p left. So remember, this is actually a 1, but we don't have to write the 1. Okay. All right. Brooke, how about number 8? B to the second. Very good. Again, we can't take any number out. So it leaves us with 2 plus 3b plus 6b squared. Everybody getting the hang of it? Okay, number 9. Tori, how about number 9? Take a 2. Can we take a k out? No, no k's. All right, it leaves us with 3k to the 5th minus 2k plus 6. All right, Allie, the last one?
I put
1p, good. Leaves us with p squared plus p minus 5, and we're done. Okay. Okay. So I'm going to start, we're going to go over the next phase of factoring, but I will not give you homework on that tonight. Okay. Let's see. So the first thing we do when we factor is we factor out the greatest common factor, all right? So what we're doing, the reason we're factoring is that we're working our way up to being able to solve equations that look like this, okay? And in order to solve them, we have to factor them first. So let's say that we have x squared plus 5x plus 6, okay? Now, in order to solve that, right, if it was an equal sign, I would have to factor it first. We will do that later. For now, we're just learning the skill of factoring. Okay? All right, so we're going to get progressively more difficult with the factoring. We started off with the simple factor out the greatest common factor. Now we're factoring quadratics. This is called a quadratic. How do I know it's a quadratic? If I had just x plus 4, that would be what we call linear, which means when we graph it, it's a straight line. Okay, Grady, how do I know this is a quadratic?
X squared.
Because it's x squared, yes. Because this is x squared instead of just plain old x. When you graph a quadratic, it looks like a parabola. It looks like a parabola. You know how I remember that? Bowl, right? That's how I remember it. Parabola. Looks like a bowl. Okay? So this is a quadratic. We're going to work on factoring quadratics right now. Okay. For now, for today, everything I give you, no, I shouldn't say that. Before we factor it, we want this to be a 1. Okay? That's a 1. Okay? The first thing that we do is look to see if there are any greatest common factors. So if I look at that, is there anything I can factor out of that? No. Just a 1, and that doesn't really change anything, right? So we're good with that. Now what we're going to do, we're looking for two numbers that multiply to equal 6, but add up to 5. Give me two numbers that multiply to be 6, but add up to 5. 3 and 2. So this is going to factor like this. We're going to make two parentheses. We're going to put an x in each parenthesis. And then we're going to do plus 2, plus 3. And it is factored. I can check it by multiplying it back out. Factoring is like the opposite of foiling. Factoring is the opposite of foiling. If I were to FOIL this back out, I'd get x squared plus 3x plus 2x plus 6, which equals x squared plus 5x plus 6. Factoring is the opposite of foiling. So we can check our work by foiling it or by distributing it, okay? Okay, let's do another one. Remember, we always look for that greatest common factor first. Okay, so let's do, all right, let's do 2x squared plus 24x plus 40. Did I start the recording again? Yeah. Okay. We always look for the greatest common factor first. Is there a greatest common factor? 2. So let's take the 2 out. Leaves me with x squared plus 12x plus 20. Okay. Now that we've taken the 2 out, now we're going to factor this part right here. So it's going to be 2, and I'm going to make my two parentheses. I'm going to put x in both parentheses. Okay. Everybody see that? Now, two numbers that multiply to equal 20, but add up to 12. 10 and 2. And we're done. It does not matter if you write it like this, it's the same thing. It doesn't matter which order you put it in because we're multiplying. This is 2 times x plus 10 times x plus 2, and it doesn't matter what order we multiply. Okay? So this is factored. This is equivalent to 2 times x plus 10 times x plus 2. Okay, if I multiply that back out, it's going to equal that. All right, let's do another one. Let's do x to the third plus 8x squared plus 15x. Notice there's no equal sign, right? There's nothing to solve. We're not solving yet. We're just rewriting it in a different form. Okay, so what's the first thing I always look for? The greatest common factor. Is there anything that goes into all three of those? X. So let's take an X out. And we're left with x squared plus 8x plus 15. Everybody good so far? Okay. So we have x. I'm going to make my two parentheses. What do we put in the beginning of each parenthesis? X. Give me two numbers that multiply to equal 15, but add up to 8. 5 and 3. So x plus 5, x plus 3. Okay. Okay, I'll do another one. Yes. So let's just pretend that this was maybe a 10, right? There's no, you can't find two numbers. 10 the only factors of 10 are 1 and 10, 2 and 5. That's the only way of multiplying two numbers to get 10. Neither one of those add up to 8. So you would just leave your answer like that. Okay, very good question. Okay. Okay. So let's look at another one. Let's look at, okay, we're going to do a little bit harder. 3x squared plus 3x minus 60. What do we do first? Take a 3 out. Good. X squared plus x minus what? 20. Okay. Now this one's harder because I have a negative 20 but a positive 1. So let's think of what multiplies to equal 20. 1 and 20, 2 and 10, 4 and 5. Is there some combination here where 1 is positive and 1 is negative? Okay, because in order to get negative 20, one of these numbers has to be negative. Not both, but one of them. Which one would work? Negative 4 and positive 5? Well, let's see. Negative 4 times positive 5 is negative 20. Negative 4 plus 5 is positive 1. So that works. So we've got the two parentheses. We have x minus 4 and x plus 5. It worked. Okay, so they definitely get harder when you've got negatives in there. Okay, here's another one. Let's do 2x to the third plus 8x squared minus 120x. What do you think? What do we always do first? Factor something common out of it. So what can we take out?
2x.
2x, good. Leaves us with x squared plus 4x minus 60. Okay, I'm going to give you a minute to see if you can do that. Finish factoring it. Okay, so we have 2x, and then we're going to make our two sets of parentheses. We put an x in both parentheses. Now I'm looking to factor the 60, right? 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, right? I need it to be negative, so that means one of those numbers has to be negative. Which one can I use to add up to positive 4? Yeah, I mean, right away, we know we can eliminate the 1 and 60 and the 2 and 30. They're going to be too big, right? If it's a negative 2, we'd get a positive 28. If it was a negative 30, we'd get a negative 28, right? Same thing here. These are too big. 4 and 15, opposite signs. It's going to come out to be 11. 5 and 12, that's going to come out to be a 7. 6 and 10, now we're going to get a 4. So if I use negative 6 and positive 10, I get negative 60, and that adds up to positive 4. So it's going to be negative 6, positive 10. Okay. Okay, let's do x squared. Let's see here. Minus 7x plus 10. Is there anything common?
No.
Okay, so let's make our two sets of parentheses. We're going to put x in each parenthesis. Now I need two numbers that multiply to equal positive 10, but add up to negative 7.
Negative 2 and negative 5.
Negative 2 and negative 5. Well, what's negative 2 times negative 5? Positive 10, right? Negative 2 times negative 5 equals positive 10. What's negative 2 plus negative 5? Negative 7. So that works. Notice, right? If it was x squared plus 7x plus 10, how would that factor? That would be x plus 2, x plus 5. Notice, okay, this is important. Everybody pay attention now, right? Because you're getting a little bored. If this last number is positive, then the signs have to be the same. If that last number is positive, the signs are the same. How do I know whether to use a positive, a plus, or a negative with my factoring? It's based on this. The signs are the same, but I used a negative. Here, the signs are the same, but we used a positive. Okay. If that last number is negative, like this example, then they have to be opposite signs. Okay. Okay, let's try another one. Let's do 2x squared plus 8x minus 120. And have you do this yourself. Dana?
That's pretty easy.
Okay, we take a 2 out first. Leaves us with x squared plus 4x minus 60. So we know that's going to be x plus 10, x minus 6. That was dumb. Okay, let me give you one that you didn't have before. Oh, here we go. This is a good one. Let's do 4x squared minus 36x plus 56. Oops. What's the greatest common factor that you took out? 4, good. So we've got x squared minus 9x plus 14, good. Okay, get our two sets of parentheses. And we've got x in both parentheses. Now they have to both be the same sign, so they both have to be minus. And we get 7 and 2. There we go. Now we are fully factored, okay? All right, good job.
He says minus. Negative.
There's no problem.
Yeah, you said